Okay, let's see some other examples. Um, Question number 10. Question number 10 says, how long will it take $770 to be worth 1,000 if it is invested at 6% interest compounded quarterly? So you have 770 today, and you invested at the interest rate 6%, and the interest rate is compounded quarterly. So we divide this by 4. Okay, by 4. Well, now we don't know how long it will take us to change our 770 into 1,000. So we don't know how many years will make this happen. Therefore, we assume so the number of years is what we want to find. So x represents the number of years. This is our variables. So number sorry, it's very hard to write using the touchpad. Number of years. Okay, so x is number of years. Because the interest is compounded quarterly, so we have 4x. So 4x is the exponent, and this expression equals the right hand side is 1,000. Okay, it's 1,000. Now our goal is to solve for x. So first, if we divide by 770 on both sides, we're gonna have a 1 plus, and let's see, 0.6 divided by 4. That's 0.015. Gonna be 100 over 77. Okay, so 1.015 to the power 4x equals 100 over 77. Then, if we apply the same techniques we saw before, we apply a natural logarithm. So natural logarithm of 1.015 to the power 4x equals natural logarithm of 100 over 77. Let me erase this, okay, so I can have space to write. So we have a 4x. So 4x is moved to the front of a natural log of 1.015 equals natural log of 100 over 77. Okay, now then we divide by the natural log of 1.015. And then we divide by 4 because we only want to solve for x. Okay. So now let's compute what does this number equal. So 100 over 77 and the natural log. Okay, so this equals natural log of 100 over 77. Then we divide by natural log of 1.015. Okay. And then don't forget to divide by 4. So x is around this. Let's take a look at what is the requirement. We wanna run our answer to the nearest tenth. So that's 4 points. So which means we wanna only keep one decimal places. So 4.4. That's our answer. Okay, let me do this again. If you don't know how to use calculator. So first we compute this part. So 100 over 77, and then you take the natural log. So you figure out this, and then divide, and then you click on 1.015, and you click on the natural log. So right now you have this number. So 0.0148 is this number, is the natural log, and then you click on enter. So far you have the you figure out the quotient of log 100 over 77 of log 1.015, and then you divide this number by 4. Okay. Okay, now let's take a look at another example. Question 13 and 14, we are asked to solve the logarithmic equations. To solve this equation, we're going to use the property, the logarithmic properties, which we started yesterday. Friday. So let me talk about number 13. Here we have a common log of x plus a common log of x plus 9, and this equals 1. So first we're gonna simplify the left-hand side, which we use this property. If you still remember, so say log r plus log s, and this can be written as a log of the product of r and s. So by using this property, the left-hand side we can combine as log of x multiplied by x plus 9. Okay, and this equals 1. Now, we mentioned that for the common logarithm, the base is 10. So next, on the right hand side, we rewrite the 1 into a common logarithm. So that's going to be log 10. So therefore, we have a log of x plus 9. Sorry, log of x times x plus 9 equals log 10. So we have x times x plus 9 equals 10. So by doing this, we convert the original equation, the logarithmic equation, into a quadratic equation. Right. So let's try to solve this equation. So x squared plus 9x minus 10 equals 0. So we can factor. Okay, we can factor the left-hand side as x plus 10 times x minus 1. So we have two solutions. One is x equals negative 10 and x equals 1. So here we're going to drop this solution. We're going to drop negative 10. This is because we said when we introduced the logarithmic function, we said the domain has to be positive. So that's why x cannot be a negative number. So therefore, there is only one solution. That is okay. That is 1.